press the bell icon on the YouTube app and never miss another update.
Hello dear students, let me continue lecture number 2 from work energy power. Okay, so let me continue the second part of work energy and power, WPE, work power energy. Okay, part 2 lecture. Anyhow, in part 1 I covered very basics. In a very easy way I covered very basic things like meaning of work and unit of work, dimensional formula of work, and units of work. Joule I defined, erg I defined, and I written some work done by constant force, work done by variable force equation, and area under Fs graph gives work done, we know, and we know in few cases work done may be positive, may be negative, may be 0, and we know work done is the dot product of two vectors. What are the vectors? Force and displacement. So that's why work done is a scalar. Of course, this is a scalar chapter completely. Okay, because power also a scalar, energy also a scalar. That also I will show you everything. Now today in this lecture, let me cover some concepts. These concepts will give some confidence to solve problems from any type of book. Again, let me start some easy level of concepts. Based on the time and situation, I am going to show some depth. Okay. Now write down the heading, concepts on work or otherwise work done in different cases. So you can take it as some note. Note means all these formulas are useful for entrances and of course used to solve problems from NCERT and from any other book. So this will give some confidence. Okay, concepts. So work done in different cases. Work done in different situations, different cases. Otherwise concepts. Okay, in physics, if you are good in concepts, definitely you are going to enjoy the problems. Most of the first PUC students generally they struggled with solving problems. Okay, why? Because they are unable to understand the concept clearly. So to solve the problems in an easier way means first you try to understand the concept. Okay, I am going to start very easy level concepts for this class. Maybe slowly I am going to extend concepts level. Okay, if you enter into the next chapter, I will show you so many varieties. Okay, based on the situation, I will show you everything. Here, work done in different cases, otherwise concepts. Let us see. Means some applications. You try to maintain each and every point clearly. Okay. See, just you see now. There is a block whose mass is m. Now I am going to lift this block through a height h, already covered in the last class. So I lifted. See the arrow mark. Arrow mark means I am lifting that. Now there are two formulas here. If a block is lifted, work done by the lifting force, one formula. Work done by the gravitational force, another formula. So lifting means we are lifting up. So already covered in the last class. So lifting is up, gravitational force, Fg I am writing down. Now let me write two formulas here. Work done by the lifting force. I hope you remember this thing. Work done by the lifting force is, tell me lifting force. Force is upwards, body also moving upwards. We can write F into S. Lifting force is in this direction. Okay, F lifting. Angle between lifting force and H both are in the same direction. So cos 0, and this is mg, F nothing but mg, S nothing but H. Then what is this work done? Work done by the lifting force is positive, and in the same way work done by the gravitational force, already written in the last class. Let me start from this gravitational force. Tell me which side the gravitational force is acting? F suffix G. Okay, you don't write F into G, F suffix G, Fg cos 0. Is it 0? No, no. Force is downwards, body moving upwards. So cos 180. Cos 180 minus 1. Fg is nothing but mg. S nothing but h. Cos 180 is minus 1. See? So two situations. Work done by the lifting force is plus mgh. Work done by the gravitational force is minus mgh. Why? Because gravitational force is downwards, body moving upward. Angle between force and displacement is 180, then minus mgh. Already written in the last class, but let me maintain the order again. So take this as a one formula. Okay. Now see, first suppose if a block whose mass is m and moving under the application of force with a uniform speed, if the block is moving with uniform speed means, tell me how much the work is said to be done in this situation. Uniform speed, generally we can write W is equal to Fs, body moving in the direction of force, theta 0. F nothing but we can write ma, because S is not given here. Okay, ma, yes. What is this A? A is 0. Why A is 0? Tell me why A is 0? Because the body moving with uniform speed. Uniform. So uniform speed means what is the acceleration? Acceleration 0. Then how much the work done? Work done is 0. Of course there is a displacement. But how the body is moving? If the body moving with a uniform speed, then work done by that body is 0. Uniform speed means acceleration 0, so there is no work done. So keep in mind. Okay, this is simple thing. Work done when a body moving with a uniform speed is nothing but 0. Okay, I do know work done by the frictional force. For suppose, let me write this one. Block of mass m, written this one. I applied a force F. Okay, use this knowledge to solve problems, and coefficient of friction is mu. What is this? This is F applied. Applied. Yeah. Yeah. Because of this force, the body maybe covers some displacement S. Tell me, how much the work done by the applied force? By the applied force I am asking. Applied force is right side, displacement also right side. Angle between them how much? Okay, speed up little bit at least so that I can continue some good questions. Applied force is right side, displacement is right side. Then, so I am writing here because here the space is not sufficient. Let me write here. For this one I am writing like here. Work done by the applied force. Work done by the applied force. F up, W applied. Work done by the applied force is F applied into distance. Okay, if applied force is given something 10 Newton, displacement is something 2 meter, 10 into 2, positive. Work done by the applied force is F applied into S. If F is given, S is given, direct substitution. And see what force is acting this side? Fk. Tell me what is the work done by the frictional force? I will remove this now so that I can write neatly. So work done by the frictional force. Frictional force is F, nothing but friction. Shall I write Fk into S? Why Fk into S? Tell me. Fk left side, S right side. Angle between them 180. Cos 180 minus 1 minus Fks. Okay, minus Fks. Now let me write one more. Work done by the resultant force. See, three formulas here, very basic formulas. Resultant force. So R for resultant, Fr into S. Fr into S. What is R? Nothing but resultant, net force. Net force is nothing but, if this is more, generally applied is more. So Fr nothing but F applied minus Fk into S. So three formulas. When a body is on rough horizontal surface, then there are three work done. If a block is placed on rough horizontal surface, then keep the first one, work done by the applied force formula. Okay, work done by the frictional force, work done by the net force. Okay, if it is moves with some acceleration A, you can write this S as ut plus half at square. Use the kinematics. Kinematics will helpful for all other chapters. Okay, if it moves with uniform acceleration A, uniform speed means 0, just now written. If it is given with uniform acceleration, then S is equal to ut plus half at square. Okay, right, if they given S, you substitute S value. Here if the body moving with some, under the application of this force, the body moving with 2 meter per second square. What they given? Is they given yes? No, they are not given displacement. They given acceleration. If they given acceleration, then use this S as half at square, and remaining is easy. Okay. I will give you one simple problem for this. Apply this knowledge for solving problems from NCERT and other books. I will give you one simple thing. Find work done by applied, work done by friction, work done by the resultant force as shown. See, I am writing problem in a shortcut way. Okay. See, the diagram is looks like this. 4 kg. Mu is equal to something 0.5. Applied force is 10 Newton. 10 Newton, so that it moves with an acceleration A. A is equals to, they given 2 meter per second square. See, they are not given the displacement. Find this one. I given simple example, just general example I am giving to get some confidence. What is this? Applied force. And what is acting backside? Fk. No, Fk is not given. Tell me how to get Fk. Fk you know. Mu k mg. Okay, let us start applied force. Work done by the applied force is F applied into displacement. Displacement is not given. Okay, displacement is not given. Okay, after something 2 seconds, if time is given, anyhow everybody starts from rest, so you can write F applied is 10. This is ut plus half at square, half a square. Okay, if S is given, substitute S. If S is not given, they will give definitely A and T. Then you convert this S into half a t square. Half a to t square, 4. So 2, how much the work done? 10 Newton. 10 Newton. Sorry, 40 Newton. Now coming to the frictional force. Fk into S. What is Fk? I think you know mu mg. Remember the formula? Mu k mg. Fk nothing but mu k mg. Mu mg. Mu mg into S. So mu 0.5, mass 4, g 10, S half a t square. So substitute the value 0.5. 4, this is 2 into 10, 20. A 2, this is 4. Okay. So 2, this is 1. Again, how much it is now? 4. See, I am getting work done by the frictional force is more I am getting. That means, see, how much I am getting? 80 Newton meter. Okay, 80, this is joule. Okay, data, simply I am taking any data, 80 joule. Check it, is this problem is possible? So this is the way of analyzing the problem. See, I am simply given the values, how much I applied? 10 Newton. Then how much the applied work done? So work done by the applied force, how much? 40 joules. But how much the frictional force? 80 joule. That means what? Is that block will move with this much acceleration? Tell me, just you think it. Is this block will move with this acceleration? So given data itself is wrong. Why it is wrong? Tell me. Okay, if you understand the wrong means that is the good sign. Tell me. 80 joule. Backside 80 joule. Work done by the frictional force is 80 joule. Work done by the applied force is 40 joule. So acceleration is not possible. Okay, acceleration is not possible. Okay, better. So here in a first situation. So anyhow, given data is wrong. If this is more, then the block will move forward. Okay, so no problem, no need to worry. Let us suppose first situation. For a first situation, let us take S is equal to something 60 meter for first situation. Then, okay, anyhow you understand the theme. So this given data is wrong, sir. Okay, 80 joule. 80 joule is the work done by the frictional force. 40 joule is the work done by the applied force. The block won't move, so this acceleration is not possible. So what I am changing now? Now I am changing the question because we are solving the problem. Okay, if they given like this, given data is wrong. Work done by the frictional force is more, so this block never move. Block is at rest only. Then there is no acceleration. In a first situation, let us change the data. Okay, first case is possible. Data is wrong. Data is insufficient. That is also no problem. Okay, first problem only, data is insufficient. Nothing will happen. Okay. No need to worry. Problems means we have to enjoy, that's it. First starting problem is insufficient data, but I think you understand why it is insufficient. That is enough from my side especially. This is 40, this is 80, so not possible. Okay. Now coming to the small, let us change the data. Okay, if you solve the problem from the textbook, we will get perfect. Same type of question is there in NCERT, you try to solve it. Okay, same model is there. Work done by the applied force, frictional force, resultant force. You try to solve problem from NCERT by using this knowledge. Anyhow, first case, let us suppose the displacement is given. First situation, in NCERT they given first situation. For this one they given yes. In NCERT problem. How much it is? 60. Okay, displacement is 60. How much it is applied force? 60 into this is 600 joule. And second situation, they are giving with acceleration. Okay, see, I written the problem in a shortcut way. That's why I am getting wrong answer. Not wrong answer, data is wrong. That's it. Okay, we are not wrong. Data itself is wrong. Okay, so work done by the frictional force is 80. Now work done by the resultant force. Work done by the resultant force is F applied minus frictional force into S. Use this S value. Okay, this is third problem. Second problem, I think you are followed what I am means how I am extending. Okay, I am changing, for getting the answer I changed the values. They will give any type of problem. Okay, applied is how much? Applied just 10. Frictional force is mu mg. Okay, Fk is mu mg. How much mu? 0.5. M 4, G 10. Okay, 0, 5, this is 20 Newton. This is 10, this is 20, and how much is 60 meter. So again how much I am getting? 10 minus this is 10, minus 600 joule. Okay, so use correct data from NCERT textbook and apply this knowledge. Here I am getting minus 600, don't worry about these values. Anyhow, you got the idea. If this is more and this is less, then only the body will move. But what I got this is more. So the body won't move, then there is no acceleration. Okay, so no need to worry. Use the proper data from NCERT textbook. Okay, here your target is how I written the formula. Work done by the applied force, how I written. Work done by the frictional force and work done by the resultant force. Okay, so no need to worry. These numbers are so many. Okay, here I am not compromising because the method is correct. Okay, yeah, let us see one more concept. Next concept, maintain the points. Okay, try to solve problem from NCERT by using this knowledge. Now let me write the next concept. Work done in lifting a block of mass m through a height h against the gravity from a non-viscous liquid of density rho L as shown. Yeah, see, I written some words here. See the concept. I want to find out the work done in lifting a block of mass m through a height h against the gravity from a non-viscous liquid of density rho L as shown in figure. See, they given this diagram. Okay, so simple concept this is the non-viscous liquid whose density mentioned as a rho L. Okay, density of this liquid is rho, I am using suffix L, rho L, and see there is a block. Okay, there is a block whose mass is m, whose density rho suffix B, B for block, B for body, and this is going to be lifted to the top or some height h. Yeah, it is lifted like this. See, a block of mass m or a body of mass m is inside the water at a depth of h. Now to lift that body through a height h against the gravity, see, gravity is downwards. Now I am lifting that body against the gravity inside the liquid. Okay, liquid density is given. So rho suffix L is the density of liquid, rho suffix B is the density of the body. Now to lift this body through a height h, then some work is said to be done. Got it? To lift this body through a height h, definitely some work is said to be done. Now our target is to find out how much work is said to be done in lifting a body through a height h inside the non-viscous liquid. So written these words. Okay, let us see how much the work is said to be done. Anyhow, work done is mgh, minus mgh. Why it is minus mgh? What they are asking? Against the gravity. Gravity is down, you are lifting up. So they are asking work done by the gravity only. Gravity is downwards. Okay. So work done is minus mgh, no doubt. M does not change. Means they given density. And height remains same. What is changes? Gravity. I think you know gravity is different at different places. Here effective gravity is different. That effective gravity we have to calculate. Let us see how to calculate effective gravity. Once it is lifted to a height h, you know the weight of this body, weight of the body always acts vertically downwards. Recall the free body diagram concept. So take this as a point mass. What is the weight? Weight of the body always acts vertically downward. Weight is acts vertically downwards. And see, this liquid will apply some any upward force, net upward force. Definitely this liquid will apply some net upward force. That net upward force, call it as FB, call it as buoyancy, force of buoyancy. You know Archimedes principle in the lower classes and force of buoyancy word also in the lower classes. So liquid, so some upward force is acting on the body by the liquid. So that upward force, net upward force acting on the body by the liquid called as force of buoyancy. Okay, force of buoyancy. Okay, B buoyancy, force of buoyancy, BUO. Okay, force of buoyancy. This force of buoyancy nothing but weight of the liquid displaced. I think you remember Archimedes principle like that. Force of buoyancy nothing but weight of the liquid displaced. Then what is the net force here? Net force directly I will write in a matter of one step or two steps. Okay, let me write now. Net force nothing but one is downwards, other one is upwards. So weight of the body minus buoyancy. This is the net force. This is more. Okay, weight of the body minus FB. This F net, let me write mg effective, E for effective, G net, E for effective. This is, we can write it as volume. Mass, you know, mass can be written as volume into density because density is equal to mass per volume. Mass, what is this mass? Mass of the body. Okay, let me write later, the next step. Mg of body. What is this? Mg of liquid means weight of the liquid displaced. Weight of the liquid displaced. So this is mass of the body, means mass of the body we can write it as volume of the body, density of the body. Got it? Because density is equal to mass by volume. Mass is equal to volume into density. G effective, E for effective, net. This is volume, density of the body and gravity. Okay, same amount of volume will be displaced. Volume will be same. And what is this mass? Tell me. Mass is nothing but mass of the liquid. Mass of the liquid nothing but volume of the liquid into density of the liquid. Volume of the liquid, density of the liquid. Volume will be same. Same amount of volume will be displaced. Volume is same. Volume of the liquid, density of the liquid into gravity. Volume you can strike off it. Okay. Rho suffix B, G effective. Let us take rho suffix B, G as a common. This I am taking common. This is 1. This is G already taken out. Rho suffix L by rho suffix B. Rho suffix B cancel. G effective is equals to G into 1 minus density of the liquid, density of the body. This is the gravity. This is the gravity. So gravity changes to this much. Okay. Now let me write the formula. Therefore, work done against the gravity, no doubt, minus mgh. M nothing but as it is, G nothing but G effective. G nothing but G effective. This value. Height is same. Mass you keep as it is. G becomes G effective. Then what is the formula? Minus M. G effective is this value, write it. G into 1 minus rho L by rho B. Now I write H here. 1 minus density of the liquid, density of the body. This is the work done against the gravity when lifting a block of mass m through a height h in a non-viscous liquid. Downside is visible. Yeah. What is the formula I am getting? Minus mgh 1 minus rho L by rho B. What is this rho suffix L and rho suffix B? Rho suffix L is the density of liquid, rho suffix B is the density of body. And we can write this is in other format also. If any, shall I write space? Yeah, let me write one more extra step. W, which is equivalent to minus, is it visible? Minus mgh 1 minus, see, 1 minus rho L by rho B. I am writing 1 by S. See, I written one more symbol S. What is this S? Where S, which is equivalent to rho B by rho L, call it as specific gravity. It is called it as specific gravity or relative density. Keep in mind specific gravity, otherwise it is called as relative density. Relative density. Downside everything is visible. Got the formula finally? I am using plenty of steps, okay? So you have to get some confidence, that's why I am doing everything now. So what is the formula for this concept? Okay, if they given this type of problem, if you remember this, just you will get the answer in a matter of seconds. Okay, within some 30 to 40 seconds we can finish the problem. Okay, if they given the problem is like this. So remember the formula. Formula is our target. If possible, learn every formula with derivation. That is the better way. Okay, no need to remember the derivation. You remember the way how to derive. That's it. Okay. So that is the specialty of concepts. I got finally minus mgh. Why I written minus? We are doing against the gravity. Okay, against the gravity. This is weight of the block mg. Body is pulled up. Completed. What is that last S? Specific gravity, otherwise relative density. Relative density nothing but density of the body by density of the liquid. Okay, generally at 4 degrees centigrade we will take. So these specific gravity and all the formulas will come in fluid mechanics chapter in a first PUC only. Okay, fluid mechanics, mechanical properties of fluid. There we are going to learn relative density terms. It is nothing but density of the body by density of the liquid. Ratio of the density, no units and no dimensions. It is a ratio. Okay. Add one small problem for this. I'll give one small problem. Find, I am writing correct question now because earlier if I written some direct question, we got calculation something different. Now let me give the question from the textbook. It's a better way, so that we will get correct answer. Okay. So starting problem itself only I given some data is insufficient. No need to worry. Okay. So find the work done. I am giving the proper question now. Find the work done in lifting. Okay, generally we will play with problems. That's why I did starting, but that is also good. Okay. So find the work done in lifting a stone of mass 10 kg and specific gravity 3 from the bed of a lake to a height of 6 meter in water. Okay, so I given proper question, no doubt you will get the correct answer. Take G as a 9.8, otherwise you can take G as a 10, that's not a problem. Okay, your wish. G 10 meter per second square. Specific gravity is given, otherwise they have to give density of the liquid, density of the body. If they given density of the liquid and density of the body, use this formula. Substitute density of the liquid, density of the body. Right now in a given problem, specific gravity is given. They are not given Royal Roby. S is given. Anyhow, we have a formula. What is our formula? Minus mgh 1 minus 1 by s. What is this m? 10 kg. G 10. Height 6. 1 minus this is s, nothing but 3. Specific gravity 3. It does not have any units and dimension formulas. Okay. So 100, this is 600, 2 by 3. Okay. 400 joules. Now see the critical numbers. 400 joules. Okay, use these concepts to solve some other variety of questions. Okay, follow the same method to solve. If they given Royal Roby, substitute Royal Roby. Completed? How much time I am taking? Yeah. Okay. Let me enter for next concept. See the next concept, means next formula and concept. See the given, okay, just listen, next you write. The given this diagram like this. A person is standing here, he is holding some rope. Yeah, see here. Okay, a person. Okay, this is the person. Okay, here a bucket. This is a bucket. Okay, this bucket full of water is to be lifted by the rope by the person. Okay, this bucket full of water whose mass is something capital M. Okay, bucket full of water of mass is capital M. That is to be lifted with the help of a uniform wire whose length is L, whose mass is M. Whose length is L, whose mass is M. Okay, that this will be lifted by the person against the gravity. Then tell me how much work is done by that man against the gravity in pulling the bucket full of water to the top. Let me write some words. So the work done in lifting a bucket full of water of mass capital M with the help of a rope with the help of a rope wire, rope of mass m, length L, against the gravity is, then tell me. Okay, words are our interest, just you follow the theme. So what I want to write, work done in lifting a bucket full of water of mass m with the help of some rope whose mass is uniform rope, okay, whose mass is m, whose length is L, against the gravity. Okay, we need to find work done against the gravity. Okay, tell me how much work is said to be done in lifting a bucket full of water onto the surface by the rope, with the help of rope, with the help of a string. Here bucket full of water is considered as a point mass. So total mass of this bucket full of water is concentrated here. This is considered as a point mass. So this is a point mass. So work done, we can write it as, anyhow it is negative because against the gravity. Against the gravity means negative. This is to be lifted. At what height it is lifted, tell me? Okay, if L is the length of the rope, then at what height it is to be lifted? L height. Okay, L height. So mgh formula, mgh, capital M, G, H nothing but L. But answer is not yet completed. Don't write only mgl. There is some work is done by the rope also. So for the rope, see this is for bucket. This is for bucket. For the rope, mass of the rope, gravity and length of the rope. But it's not length. It is mass. See, rope mass is there from here to here. It is a uniformly distributed wire. Then you can go for the center of this one, center of gravity of this wire, midpoint of that wire, because this is a uniform wire. Actually this is a center of mass. This will come in the next chapter. Okay, center of mass means the total mass of the body is concentrated at that point. Keep that word in mind. It will come detailed in the next sessions. Means in the coming chapters I am going to enter into the center of mass. Okay, right now you feel that this is the center of mass, midpoint. Okay, so height of center of mass of this wire. Why? Because if entire mass is there, see here for the wire will be there from the bottom to the top. Then you can take the midpoint of that wire. Okay, the same concept will come in the continuation. Cylinder will give. We will take height of the cylinder only. We cannot take as a h. H by 2 we will take. Okay, that h by 2 nothing but center of mass. Okay, midpoint. Right now midpoint. Okay, center of gravity or midpoint. So here for this wire you can write mg, and mass is distributed from this place to this place. Length also there from here to here. So you write midpoint, mg L by 2. So this is the formula. For the bucket, from here to here is L, because bucket mass is up to here only. For the wire mass starts from here, wire mass end up to here. Length also here. So take the midpoint of that wire, mg L by 2. Okay, actually center of mass. For a uniform distributed objects, keep in mind, for a uniform distributed object, you can go for the center of mass. Wherever the h is there, you can take the midpoint. If h is equal to, see, h nothing but center of mass. H is the mgh is our formula. H you can take it as a midpoint of that system, midpoint of that wire. What is the midpoint? L by 2. Mg L by 2. So this is the formula. Mgl for bucket. Mg L by 2 for rope. Okay? Because rope is a uniform distributed mass with uniform linear density. If it is a non-uniform linear density, again we have to use integration process. Okay, see the next concept. So for the rope, what I written? mgl by 2. Okay, don't write mgl, small mgl. Don't expect as a capital M plus small m into gl. Don't expect like that. Now see one more concept. Simple thing, simple pendulum. I think you know simple pendulum in the lower classes. Okay, you have an idea, general idea. What is simple pendulum? If any heavy point mass suspended by inextensible wire from the rigid support, call it as a simple pendulum. Okay. So this will come in the simple harmonic motion in our first PUC chapters, so no need to worry. So this is the simple pendulum whose length is L. This is the point mass M. Now I want to pull this pendulum through small angular displacement theta. So to pull it through a small angular displacement theta, definitely I need to do some work. So let us see how much work is done by me to pull this pendulum through a small angular displacement theta. Now what I am going to find out here is work done in pulling or in displacing, it's better, in displacing a simple pendulum through a small angular displacement theta against the gravity is. See, this is the concept, against the gravity is. So what is the formula? Against the gravity. Is it visible down? Yeah. Work done in displacing a simple pendulum through a small angular displacement theta against the gravity I want to find. See, this I want to displace like this, so that the pendulum will comes here. Now I am applying a force in this direction. Okay. See, initially the center of mass of this bob is here, and next the center of mass will rises by some height. See, I am using center of mass word. Okay, feel that total mass of the body is supposed to be concentrated at that point. Okay, in detail it will come in the next sessions. Okay, don't feel that word as a new. It is nothing. Okay, and see, this is the height of center of gravity or center of mass. Okay, height of this one. Tell me how much work is said to be done, because initially the bob is here, next the bob is at this much height. Indirectly the bob is lifted at what height? H height. So mgh. So what is the work done by the gravitational force? Minus mgh. Wg, G for gravitational, work done by the gravitational force, work done by the gravity, G for gravity, W suffix G, don't write W into G, W suffix G, minus mgh. Tell me how to write this h. Okay, this is displaced through a small angular displacement theta. Total length is L. L is the length of the pendulum, from here to here is the length of the pendulum, center of mass of the bob. Okay. What is this height? Tell me, how much this height? L minus H. L minus H. So this is L minus H and this is L. Okay, this one. See the way I am pulling this one like this. So this is L, complete is L, and this is L minus H. Don't think this is L minus H. Okay. See, from this triangle, tell me the cos theta value, cos theta. See, this is adjacent side, this is opposite side, hypotenuse. Cos theta, we can write it as L minus H by L. So, L cos theta is equal to L minus H. Okay. H is equals to L minus L cos theta. H is equals to L into 1 minus cos theta. So what is this H? Substitute H here. What is the H from the given diagram? H nothing but L 1 minus cos theta. So this is the work done against the gravity by pulling the simple pendulum through a small angular displacement theta, minus mgl 1 minus cos theta. If they given the problem based on this, use the formula mg. If height is not given, convert that height into L and theta. Okay, pendulum is displaced through a 30 degrees from the initial position. Then find the work done by the Gravity, against the gravity. Work done against the gravity is minus mgl 1 minus cos theta. Tell me how much work is done by the force? Work done by the force, applied force. Work done by applied force. Can anyone expect? Applied. Tell me, work done by applied force, how much? Applied force. See, this is the applied force. F. How much the displacement? How much the displacement? Tell me. I think you know resolution. This is L cos theta. What is this component? Can anyone will tell? L cos theta. From here to here is L cos theta. From here to here is L sin theta. So, indirectly displacement is L sin theta. So, L sin theta. This is the work done by what? Applied force. L sin theta. I think you know component. L cos theta, L sin theta. L sin theta is the displacement in the direction of force. F L sin theta. Yeah, earlier Fs cos theta. Now I am getting F L sin theta. Don't confuse. Okay. F L sin theta cos 0 actually. Why cos 0? Tell me. F force. Displacement L sin theta. And these two are in the same direction. Angle between F and L sin theta is 0. Actually, F L sin theta cos 0. Then answer is what? F L sin theta. Okay. So practice at least twice. Easy things, not tough. Okay. Next some tough will come. Cylinders, some other things. Work done by some cylinder, when a cylinder piston will push down. Okay. You see this one.